This question also appears as question 12 on the Engineering Admissions Assessment.
So in 2017 question 26, we can see this diagram of a system consisting of a motor, a rope and a pulley lifting a mass of 20 kilos by 6 meters into the air. 12 volts are applied across the probably electrical engine inside, and the efficiency is 80%. The whole lifting happens in only 5 seconds. In order to do some calculations, let me remind you of 3 important formulas. So first of all, for the gravitational potential energy, that's mgh, mass, change in height. Then the general definition of power, especially mechanical power in this case, that's going to be the rate of change of energy, or just energy per unit time. And you might even recall from electrical circuits, it's the power of an electrical element, that's the EMF, or the voltage, times current. I actually changed it to EMF because that's better practice. Now the question is, what the current flowing through the motor will equal in order to supply enough power to lift this mass. So let's use our expression for gravitational potential energy and calculate how much energy will need to be supplied. So mgh, I plugged in the numbers, and what I got is 1200 joules. Now for the power supplied, that's our energy, 1200 divided by 5 seconds, which gives 240 watts. Important results, which I'm going to store here as the power needed to lift the object. Now the power provided by the motor is this, epsilon times I. However, remember that only 80% of what runs in the actual motor is successfully transferred to our mass, which is being lifted. So we need to multiply this by the efficiency. Remember that we need to find the current which flows through the engine. So we should isolate the current here. Now plugging in the numbers, that's 240 for the power, 12 volts and 0.8 for 80% efficiency, which gives us 25 ampere for the current which is flowing through the motor. And that was option F.